In a stunning emergency briefing that rocked the international scientific community, officials announced that Three-Eyed Atlas is now on a catastrophic collision course with Mars. The announcement came after weeks of frenetic observations, unpredictable trajectory changes, and growing concern among planetary scientists. Humanity has never seen anything like this before, a time-traveling intruder, crashing its way through our solar system, now poised to threaten a planet already frozen, battered, and full of human aspirations of exploration and habitation. The initial warnings of peril came when both NASA's Deep Space Tracking Network and Harvard astrophysicists picked up on slight but unmistakable glitches in Three-Eyed Atlas's projected trajectory. Originally expected to fly harmlessly past Mars, the comet's trajectory started bending inward, swinging toward the red planet with growing ferocity. What started out as fleeting glitches soon crystallized into a bleak fact: Mars was squarely in its crosshairs. Both stations, following prolonged analysis of the data, concluded that these discrepancies were no longer random error or transient wobble but reflected a genuine realignment, one that could be catastrophic. The situation was becoming increasingly critical with every iteration. Piercing space at unprecedented velocities, Three-Eyed Atlas was coming in with barely any room for error. Its collision path now held repercussions to reshape the Martian terrain in an instant. Unlike an ordinary asteroid or piece of space junk, this was an actively flaming interstellar comet, its nucleus expelling volatile gases, its tail growing and changing direction in ways that seemed entirely random. As it approached the Sun, it grew more active. Bursts of gas and dust erupted haphazardly, changing its brightness and velocity with every eruption. These microthrusts behaved like natural engines, nudging and tugging the comet's course in tiny but cumulatively destructive increments. What had been a common near pass had become a line of potential disaster. By the time the emergency briefing was being released, trajectory models predicted a high-probability impact window during late October. By then, the comet would be well within the inner solar system, too close for any effective intervention from Earth and traveling too quickly for traditional deflection attempts. Harvard scientists pointed out that as Three-Eyed Atlas neared its perihelion, solar heating, radiation pressure, and cataclysmic outgassing would be at their strongest. These forces might induce sudden structural changes or even breakup, dispelling lethal debris into space and towards Mars. Impact scenarios predicted were frightening. In the event that Three-Eyed Atlas were to impact the planet, the resulting release of kinetic energy would dwarf anything experienced by Mars in recorded history. Moving at tens of kilometers per second, even one fragment of the nucleus would release energy equal to several thermonuclear explosions. The shock waves, ground vaporized, and giant ejecta plume would blast through the planet's tenuous atmosphere, destroying surface facilities and perhaps expelling gigantic clouds of dust into orbit. These would blanket the Martian sky, alter global temperatures, and initiate planet-wide dust storms lasting months or years. For generations, Mars has been humanity's utmost extraterrestrial ambition, a planet of colonization and terraforming, mining and resource exploration, and hunting for microbial organisms. And now that vision hangs in the balance of extinction. An impact of this scale would not wreck bases or rovers, it could rewrite Mars's geology and atmosphere, influencing orbiting satellites, communications, and any current or proposed missions. Scientists cautioned that the fine line between robotic and human presence would be in jeopardy. In spite of the anxiety, several researchers recognized the scientific potential of such a development. The impact site would be a natural excavation area, unfurling deep subsurface units that could demonstrate ancient ice deposits, minerals, or even fossilized organic matter. But any finding would be at an appalling price: raised research stations, sterilized soil, and potentially even the eradication of any microbial life that may have survived under the Martian surface. Astrobiologists are confronted with the agonizing dilemma: the crash could both destroy and uncover the traces of life humanity has searched for centuries. If there is dormant or active microbial life still present on Mars beneath the surface, the impact's heat and chemical shock would kill it off completely. Or perhaps the impact would bring these microbes to the surface, only to sterilize them with harsh radiation. Either way, the chance at discovering unadulterated biosignatures or fossilized DNA might be lost forever. Sample caches, rovers, and labs would most probably be destroyed or rendered ineffective. Far beyond the scientific crisis is the massive political and logistical hurdle. No nation or agency controls Mars, but the crisis calls for a precipitous, coordinated action. NASA, European Space Agency, ISA, Roscosmos, CNSA, JAXA, ISRO, and many private space agencies are being asked to provide resources and expertise. Martian orbiting satellites can be repositioned or even sacrificed to collect data in extremis. Communication networks will be pushed to the limit as agencies argue priorities, exchange telemetry, and try to manage unprecedented interplanetary cooperation. However, the technical facts are stark. The comet's speed and proximity make interference almost impossible. Deflection methods developed for near-Earth asteroids cannot be adapted to this situation. The amount of energy needed to deflect it is beyond the capability of humankind. Even nuclear or kinetic impactors fired from Earth would be too late to arrive, and any countermeasures based on Mars would not have the resources or the time to make a difference. The window of useful action has closed weeks ago per the briefing. There is only to observe, model, and prepare for the impact. Perhaps the most unsettling scenario considered is fragmentation. If Three-Eyed Atlas were to break apart when under solar stress, several fragments would hit Mars in different areas, simultaneously or sequentially. The destruction would be exponentially more massive, and modeling almost impossible. Several high-velocity impacts would disperse ejecta worldwide, obliterating landmarks, unsteadying terrain, and making any rescue or evacuation effort even more difficult. The briefing left no doubt, time is running out fast. As the comet approaches perihelion, its movement becomes more and more erratic. Solar winds and radiation may nudge it capriciously, and every day brings new uncertainties to its predicted path. 1 degree of variation may change the impact zone by hundreds of kilometers. We are entering the danger zone, warned one NASA official. Each observation we make today might be superseded by tomorrow. The human side of this crisis is just as daunting. If there are any semi-permanent settlements or colonies on Mars, evacuation is necessary immediately. Panic has apparently swept through mission control rooms, with engineers, astronauts, and scientists facing impossible decisions, whether to remain and document data until the end or evaluate to save their lives. Resources, life support supply lines, and psychological pressure have become top priorities. In the meantime, on planet Earth, billions sit in nervous suspense as governments struggle to reconcile openness with the imperative to avoid planetary hysteria. Aside from the immediate danger, the impending collision has deep symbolic significance. Mars has been humanity's symbol of advancement, a frontier of hope, science, and aspiration. To have that vision jeopardized by an extraterrestrial object is a bitter cosmic irony. It is a reminder that however sophisticated our technology may get, we are still subject to the universe's capricious forces. The impending impact, if it happens, will be both a tragedy and a lesson, that no world we arrive at is ever really safe, and that the universe, in all its glory, is as dangerous as it is wonderful.